Hi everyone, I hope all of you are doing good and you are staying safe. My name is Ulrich Bazimo and I'm a process engineer. So the reason why I'm doing this video is to give you a little bit of background about myself, my education and what I do right now. So about me, I'm from Burkina Faso. It's a small country in West Africa. It's amazing, a lot of people don't know about it. I came in America in 2013, first for my master's degree at the University of the District of Columbia and in environmental engineering. And after that, I joined the University of Maryland for my second master in civil and environmental engineering. So just for the small story, I actually started as a PhD student, but then later on, I decided to just do a second master. So after that, I joined DC Water as an intern first, then as a research assistant, where I met Adrian, who was working on odor control research in wastewater treatment plants. So I picked up his research and decided to work on that as well. Um, After that, actually got a great opportunity with a consulting company where I am right now as a process engineer. So what I do essentially, it's a lot of studies, planning level studies, master plans, pilot studies on odor control project. So we actually focus on a lot of vapor phase, vapor phase odor control treatments, such as biofilters, biotrickling filters, bioscrubbers, dry media, chemical absorption as well. But we also do studies where we address odor control in the liquid as well, to chemical addition. We also do some modeling, in the plant or in the collection system. So a lot of fun stuff. So if you have any question during the live session, please don't hesitate. Just reach out and it will really be a pleasure for me to answer your question. Thank you very much. Hello everyone, my name is Ulrich Bazimo. I am a former student in the civil and engineering department at UMD. I was alpha student in chemistry class, and now I'm a process engineer with a consulting firm. So my work actually focused on odor control in the wastewater treatment plants and the collection system. And Alba and I thought that it would be good to give a presentation on that. So in this presentation, we're going to discuss on the different odor treatment options and how we actually tackle odors in the collection system and in wastewater treatment plants as well. So like I said, we'll start with some background on odor control and explain why there's a need to actually control odors in the wastewater resource recovery sector, and also explain what are the methods used to quantify odors and to actually mitigate odors emissions. Um, and then we'll conclude with one case study, and I'll give some details on the liquid and vapor phase odor control options. With the growing businesses around wastewater treatment plants, it's really important to address odors emission. A lot of businesses are complaining about odors emission from the treatment plants or from the collection system. And so it's really important for municipalities to address the odor issues. And there is also some local regulations and where we have fence lines limit that have been established to actually force and help the plants achieve the odors control strategies. And it's also important for treatment plants to be good neighbors and change the public perception of the odors pollution. So when it comes to odors, we have really two main family of compounds. So the first one is hydrogen sulfide, which is a well-known compound. It has a rotten smell, rotten egg smell type of odors. It's highly corrosive. Like I think most of us knows that hydrogen sulfide can actually promote corrosion, both in the collection system and also in different wastewater treatment units. So in addition to hydrogen sulfide, we also have organic sulfur compounds, which are mainly composed of methyl mercaptan, dimethyl sulfide, dimethyl disulfide, and sometimes carbon disulfide. We have a rotten vegetable type of smell. We also have different odors compounds. We have nitrogen-based compounds, ammonia, nitrate. These compounds are highly volatile, and usually when it comes to odor control, they are not really considered. We also have other compounds such as VFAs or other VOCs that are also contributing to odors. But really, when it comes to odor control design, both in liquid and gas phase, we usually focus on hydrogen sulfide and organic sulfur compounds. So, like I said, when it comes to odor control, mainly we have two ways of controlling odors. Either directly in the liquid, so basically preventing the odors from being emitted into the gas phase, or in the vapor phase, which is basically capturing the foul air from the different treatment units or from the collection system and treat the foul air. So for the liquid phase, we have different strategies. We can go with oxidant, pH adjustment, or precipitants. Like you see here on the right hand side, this figure, we have hydrogen sulfide is formed in general under highly reducing condition where sulfate is uh, converted into hydrogen sulfide in the liquid phase. And then depending on the pH, the H2S produced can go either in gas phase or actually stay in the liquid in the form of bisulfide. So one way to control H2S and preventing H2S in the liquid to go to the gas phase is to actually use a chemical oxidant, which will mainly convert the H2S back to sulfate, thus preventing it from being emitted into the gas phase. And for that, we can use oxygen, chlorine, hydrogen peroxide, or potassium permanganate. Now, the important thing to know is that these different chemicals are good options, but they're really site specific. So it's really based on the background studies, and they're really understanding the impacts and the impact of other compounds as well, that we actually choose the appropriate chemical here. Um, we also have precipitant. So basically, we can also precipitate H2S into solid phase. And for that, usually we can use ferric sulfide or ferric chloride, or ferrous sulfate, or ferrous chloride as well. So we have different iron salt that can be used to precipitate H2S. And again, it really depends on their impact and what is the goal of the plants. For instance, why we'll choose a chemical oxidant versus a precipitant. For that, we also need to analyze the downstream impact of the compound. Sometimes some chemicals are really effective in controlling odors in the collection system, but they have detrimental impact downstream at the plant. Here is an example of an oxygen injection unit. So we have recently installed this chemical unit in a plant in Texas. So basically, this is a super oxygenation system where we actually inject oxygen into the force main, which will end up in the influent. So to design this type of unit, basically we need a different sort of data. So mainly we need the sulfide loading, we need the wastewater flow. Of course, we need the BOD loading because the oxygen uptake rate will depend on the BOD loading. You don't want your oxygen injected to be taken up by different type of organisms. The effectiveness of this odor control technique depends on the retention time. So usually we need at least between 20 and 30 minutes retention time for the oxygen to fully transfer into the liquid phase and then convert the sulfide into sulfate or sulfide. Another factor or another parameter that we look at is the oxygen uptake rate, of course, here. We also have another liquid phase technique, which is through pH adjustment. And for that, we use either sodium hydroxide or calcium hydroxide. So as you can see here in the figure, we have the sulfate speciation in the liquid phase. So basically, at pH 7, which is usually the pH in the domestic wastewater, about 50% of the sulfide is in the form of aqueous H2S, and the other 50% is in the form of bisulfide. The fraction of H2S that can go to gas phase is the aqueous H2S. So what we do, we will shift the pH, increase the pH to levels between 8 and 10, so that all of the sulfide in the liquid is in the form of bisulfide. So by doing that, we actually prevent the sulfide to go into gas phase. This is a really great technique as well that we can use. I will say that the cons for this technique is the cost, because it requires generally high amount of chemical feeding, and so when we use this technique, it's usually for lower flows, flows between 10 to 50 mgds, influent wastewater flows. Otherwise, it has been shown to be really effective in the collection system, and also in plant or earthworks treatment, as well as in the primary clarifiers. In the field, it's really important to get accurate data, and what we use is a flux chamber in general. So this is the figure that you see here. So it's basically a chamber to which we connect different tubing to first measure hydrogen sulfide with other logs. We have other units as well that we use to measure hydrogen sulfide. But other logs are really well known and really they are really simple devices that can be used for sampling. And in addition to that, we use pumps to pump the gas from the flux chamber to canisters, and that's where we actually take our samples and we take it to the lab and we analyze for organic sulfur compounds such as methyl mercaptan and dimethyl sulfide. Here you can see a picture of it. This is a sampling that we did at DC Water, where we actually kept that flux chamber on the surface of one of the primary clarifiers, and we were collecting a gas sample for sulfide H2S analysis and reduced sulfur measurement as well. Another technique here that we use, we pretty much use the same device to collect gas samples from the secondary system as well. So this is these pictures here were during one sampling that we did at DC Water, where we wanted to measure emissions from one of the reactors. So it's really the same principle, but I'll say one important thing to do when we collect gas sample is to keep track of the wastewater quality, because these definitely have impact on the sulfide emission, and it's really important to understand the correlations, so later we can definitely understand and develop really integrated odor control systems. Other testing that we do, we actually also measure, we do batch experiments, and in this batch experiment we try to understand the formation of these different type of compounds. And like I said, the oxygen uptake rate is a really important parameter to know, and we like to measure that in different plants because in addition to the controlled vapor phase and the gas phase, we also use this data into the sulfur modeling. And the oxygen uptake rate, the retention time are really important factor. And with the oxygen uptake rate, we can actually calculate different type of biomass loading into the raw influent. And this also helps in the wastewater process modeling with the sulfur cycle included. Here we are different technique of vapor phase odor control. So basically, when it comes to vapor phase odor control, we can go with a dry media system, which is basically carbon absorption. We can go with chemical system, which is basically uh, capturing the foul air and using chemicals, different type of chemicals to actually convert the sulfide from gas phase back to the liquid phase. And we can also use biological systems, which are mainly composed of biofilters, bioscrubbers, biotrickling filters, hybrid systems. And the choice of the different odor control unit will depend on different factors such as the loading and the airflows, and also the limitation with the footprint and sometimes the client preference. So for the physical absorption, like I said, this is mainly carbon media. We have different types of media. Some are expensive, some are not, but it depends really on the performance that the clients want to achieve. So usually these systems are suitable for low H2S levels lower than 10 ppm in the airstream. It offers high odorant and odor removal capabilities. And depending on the footprint requirements and the available space in treatment plants or in the collection system, we can actually come up with one stage or two stage systems to effectively address odors. So the disadvantage is the life cycle cost. Like you know, it's this technology is really based on carbon absorption. So when the media is exhausted, the media needs to be replaced again. We also have the chemical scrubbers. It has a low capital cost in general, and it can actually adapt to different type of airstream. The main disadvantage is these systems are really complex with a lot of manipulation required, sometimes some intense operation and maintenance required for this type of system. These systems are usually not suitable for high H2S airstream. So it's important to take into consideration these different factors before choosing the right technology. And like I said, for this system, we use a lot of chemicals, and these chemicals needs to be disposed. And sometimes they end up in the wastewater raw influent. And so it's really important to take that into consideration when it comes to chemical scrubbers. We also have the biological treatment. Mainly we have biofilters, which are really common. We have different type of media available on the market. We have minerals, shell, lava, rock media. We have a long residence time requirements, 30 to 45 seconds. And they are really suitable for low H2S, sometimes between 5 to 20 ppm. Biotrickling filters actually require a lower retention time, between 10 to 20 seconds, so they are smaller. So these are really important when footprint is an issue, and they are mainly used to control hydrogen sulfide. So sometimes when hydrogen sulfide is not the only odorous compounds, this technique can be used in series. So basically use a biotrickling filters upstream, upfront, and then a carbon media in the back for as a polishing step. The advantage is it's relatively simple, much more simple to operate, and it has a low O&M cost. And as a disadvantage, is pretty expensive compared to dry media or biofilm. Another option here is the air dispersion technique. So this technique is usually used for odor control in primary clarifiers, very low odor control, low airstream, airstream with low odor strength. Right, sometimes used for polishing steps. Um, it has a low profile, but the only issue is that this unit is sometimes loud. So some clients actually uh, don't uh, don't don't adopt this technique because of the issue with the noise. So it can offer the offside impact of dry media treatment at a fraction of the cost. So it's cheaper compared to other control techniques, but it can be very noisy sometimes.